Come over here. All right. Okay. Sure.
Well, yeah, my mom had to check through my bed.
Let's see.
But somehow, my mom found an opening.
Oh my gosh,
But, I guess someone paid or something. I don't really know. It was like 10 o'clock. Oh, I have an appointment.
So I'll just bring my overnight bag.
Yeah. It'd probably be easier.
All right. So what we're going to do today is we're going to start on the flooding chapter. Yes, I am recording. So we're going to start on the flooding chapter. I want to go ahead and just show you all that I put a couple of assignments up in the Mastering Geology software with Pearson. So there's a chapter 5 and 6 review. That's just the multiple choice questions from chapter 5 and 6, kind of like the test review that we did before chapter 1 through 4. So that's up. I think it's due next Monday, so you got a week to work on it. If you want me to extend it a little bit, just let me know. Also is the next Hazard City, which is about flooding. So I got that opened up while we go through the flooding chapter. So be working on both of those. We're going to talk about flooding at least today, maybe a little bit tomorrow, and then we will shift to topographic maps, which you kind of have to look at to know where your flood is going to go and how it's going to happen. So we got a little bit of work, but I just want to get it to y'all as soon as possible so you have as long as possible to work on it. The sooner you start, the better, obviously. So let's go to the PowerPoint. And we're going to go through some of this kind of quickly because we've already talked about flooding a little bit last semester when we went through the movement of water and how streams form and flow. And so a lot of this is going to be stuff that we've already covered, but let's go through it anyway. So their example flood for this chapter is the Pakistan flood of 2010. Basically, this flood didn't, if I remember correctly, because I do this every year, it didn't actually, the water didn't fall where the flood actually happened. The water fell far upstream. And so you can see that they had a lot of rain, about a foot of rain from July 29th to July 30th. So over 48 hours, they have about 12 inches of rain, which is a lot. If we get a really heavy rain, it's like 5 or 6 inches. So getting a full foot is a lot of water. And the other part of this is all of this rain fell on the headwaters. And so that basically means that your rain is falling over a large area of a lot of little creeks and streams, all kind of separated. And then as those creeks and streams run downhill, they're going to form together. And so it's almost like a funnel effect. You take the rain over a very large area for the headwaters, and you squeeze it all down into one river channel. And it's just going to be too much for that river channel to take. So warnings were issued months beforehand, so they knew this was going to happen. They have wet seasons in this part of the world that don't come very often, and they're usually prepared for them. Issued to those living along the river. Similar weather conditions occurred in 1995 and 1997, which led to heavy flooding, just like they saw this time. There was a health crisis after the flood that contaminated food and water, unsanitary camps, and diseases started to spread quickly. That happens in a lot of floods. Anytime you see people walking around in flood waters, if it's covering your feet, you're in danger of getting some sort of infection. It doesn't happen to everybody, but if you step on something and cut your foot, usually mixed in with that water is a lot of sewage and a lot of contaminated kind of substances that you don't necessarily want in your bloodstream. So they start off with an introduction to streams and rivers. And again, this is where we're going to go pretty quickly. Remember the drainage basin? This is the part of the map where if any water falls in that area, it will end up in a particular river or stream. And so that is your drainage basin. Usually the divides between drainage basins are like hills. So if it falls on one side of the hill, it's going to go that way and end up in one stream. If it falls on the other side of the hill, it's going to go the other way and end up in a different stream. Those are your different drainage basins. Let's see. They talk about gradient, which is basically how steep your stream is. The steeper, the higher the gradient. If you have a low gradient stream, it's nice and flat and doesn't flow very fast. Kind of like the Mississippi. The Mississippi is really wide and really slow. Where a high gradient stream would be like up in the mountains where the water runs very quickly. Let's see. This is just kind of illustrating all the stuff they just went over. Here is your drainage basin. So anywhere inside this dotted line, if water falls, it's going to flow into the Fox River, and it's going to come out of the ocean right here at Site B. And then they have a couple cross sections. This shows you like a valley stream up towards the top here. And this shows you like a more widened out stream down towards the bottom. You have a low profile, low gradient here. Everything's kind of smoothed out. And you can see that up at point A, we're very steep. Down here at point B, we're very flat because everything's kind of flattened out as it gets down there towards the ocean. Let's see, the materials that rivers transport. We have our 3 different materials. The bed load is stuff that never really leaves the ground. So it just rolls and slides along the bottom of the river. It just kind of gets pushed along by the water. Suspended load gets picked up. So like when you see the muddy creeks here in Texas after a rain, that's your suspended load that you're seeing. All the silt and soil that's picked up in the water and makes it murky and brown. And then your dissolved load is stuff that you don't see. It's actually dissolved into the water in the same way that salt water looks the same as fresh water. You can't see the salt dissolved in there, but it's in there. So anything that dissolves along the way is also part of the load of the river, the stuff that it carries. Let's see, river velocity, discharge, erosion. Obviously, the more water that's flowing and the faster it flows, the more erosion that you're going to have. And so when we talk about the discharge of a stream, it's going to be in a volume per amount of time. So how many gallons per minute are crossing this particular section of the stream? That's what you're looking for. Let's see. Stream flow widens and slows for high to low gradient. Okay, so basically down here at the bottom, they're saying as your stream is up at the top and it's very steep and sloped, you're going to have a narrow kind of V shape to it. So your stream's not going to be very wide, but it's going to move very fast. As it gets down to the bottom and a low gradient and everything kind of evens out, your stream is going to widen up. It's going to be actually wider, and it's going to flow slower. And so that's why I kind of brought up the Mississippi. Has everybody seen the Mississippi at some point? If you ever get a chance and you're driving past the Mississippi, stop and take a look at it. Very, very wide river compared to what we see here in Texas. And it actually moves pretty slow, which is why a lot of boats and rivers are allowed to, or boats and like barges are allowed to travel upriver to deliver goods, because it's not that difficult to move upriver. Little cross-section areas. Remember, when you see a stream or a river, especially if you're at like a curve of the river, the middle is not going to be the deepest part. It rarely is. If you are at like a curve, the outside of that curve, where it's like the biggest arc, is going to be the deepest part, because the water's traveling the fastest over here, and so I have the most erosion. It's traveling the slowest over here, and so some of this has actually been deposited here and kind of built up that part of the stream bed. Let's see, alluvial fans, the Mississippi Delta. They're just kind of showing you how sediments move. These sediments have moved downhill, mostly due to gravity, but also when it rains and snows, that's going to help move it down here. So you can see they come down the valley, and then once they get to the bottom and they're not heading downhill anymore, everything kind of spreads out into this big wide alluvial fan. The same thing kind of happens in rivers, even when it's not that steep. So here we see the Mississippi River Delta just past Louisiana. New Orleans is probably like right up here somewhere. And so if you follow the river all the way down, it's just going to come out until it basically reaches sea level it can't go down anymore, so it spreads out. And so you see it kind of spreading out and dropping all of its sediments here and kind of building onto the land a little bit. Let's see, meandering patterns. They're probably going to talk about how rivers curve back and forth, left to right, and how on the outside of that curve, you have erosion happening, so it's like cutting away. And on the inside of the curve, everything slows down, so you have deposition happening, which is really just going to make your meanders just get worse and worse and worse. They're going to get more curvy, because like right here, I have erosion happening. So the water's running faster, and it's eating away at this bank. So the river's actually going to curve more and more and more until it comes way out here and actually gets cut off. And that's how you get these oxbow lakes, where my river used to come way out here and make a big loop. And ultimately, the water eroded straight through that loop and just kind of cut it off from the river. So it's all isolated now. Let's see. You can kind of see these. I don't know. You can see them in all the little creeks around here. If you go to Getzendaner Park in Waxahachie, it's like a little park where you can walk along the trail. The creek there in Waxahachie shows a lot of this. You can see it pretty easily. So there's lots of places. You don't have to go to like a big river to be able to see this. You can see it in little creeks and streams or out in the farm fields as you drive by. Let's see. So braided patterns, instead of just as one stream moving left to right, the braided pattern looks like a braid. You've got lots of little streams weaving in and out of each other. When I think of braided pattern, if I can go back real quick. I didn't go back. I think of driving up to Oklahoma and crossing over the Red River. When you cross over the Red River to go into Oklahoma, it's like this. It's a big, wide river basin, but not a lot of water in it. It's not filled up. And so you have these little creeks and streams that kind of cut in and out of each other. And that's a nice example of a braided stream up there. So let's see, river systems and zones. Zone 1 is going to be sediment production. So this is going to be like up in the mountains where I have steep incline, lots of erosion, and my water's moving fast. That's going to be zone 1. Zone 2 is where everything just settles out. It's kind of flat, and you're not really producing sediment or dropping it off. You're just transporting it down to the ocean. And then zone 3 is down at the end of the river where the water meets the ocean. You start to drop all your sediment out and form a delta. That's zone 3. So zone 1, up here in the mountains, you're producing sediment. Zone 2 is in the middle, where you're just transporting it downhill. And then zone 3, down here at the delta, where everything kind of slows down and you start to drop it off and form a little bit of new land, maybe, if your delta works good. Let's see, flooding. So now we actually get to flooding itself. Flooding is where essentially I have too much water in my river and it can't hold all the water anymore. And so it goes over the banks of the river. Now it's in flood stage. So literally, when is a river going to flood? It depends on the river and how much water it can hold. Once it comes over the banks, now it's technically in flood stage, even if it's just a little bit. Flood characteristics. So you have your discharge, how much water you're actually moving. You have your stage. That's the height. So if you ever, and y'all have these around here over near 45 on some of the service roads, the little like sticks that have the feet marks, that's your flood stage. So before driving into that road, you can see based on that stick how many feet deep the water is, which shouldn't be helpful because you shouldn't drive through any water that you can't see the road on. But I guess if you're gonna wing it, it's good to know whether it's 1 foot or like 5 feet, because that's gonna have very different results. And then they have a hydrograph. A hydrograph is a graph of the stream's discharge over time. So you can kind of see when your stream picks up. And I was hoping they would have a hydrograph, and then they didn't. One of the things about hydrographs, and let me go back because that was a waste of time. I'm going the wrong way. I go back to hydrographs. Here we go. One of the things about hydrographs I'm going to show you real quick is it doesn't work the way you think it would work because a lot of times we don't think about the water actually having to move from where it falls to where we see it at. And what I mean by that is if I have a chart, and this is time, and this is like amount of water in a way. There's probably a much better way to say this, but I'm going to do rain in blue. So I have a storm coming, right? The storm comes through. It drops a lot of rain. Let's say that it's a relatively short storm. So I come in. Before the storm gets here, I have no rain. And then it's going to start to rain a little bit. It usually peaks at some point, and I get my most amount of rain. And then it kind of trails off, and I get a little bit of sprinkles before it goes away, right? That's how most storms go. They don't come in like all at once. We get some like squall lines. You usually get a little bit of buildup. You get your actual raining period, and then it dies off a little bit. But the streams take a little while because while the rain is falling, the vast majority of it doesn't fall directly into the streams. And water is going to take a little while to travel. Even if I spill some water and it's going to roll downhill, it's going to take time for that water to roll downhill. And if there's grass and dirt and rocks and all these other obstacles in its way, you don't actually usually see the creeks start to rise until the storm's almost over. And so the creeks will start to rise. And then well after the storm is over, you get your peak at creek flooding. And so when you're talking about flooding, if you live near a creek or a river that deals with flooding, the flooding doesn't actually start until the rain is over. Normally. Now, if it's raining a very long time, like for several days, then obviously your flooding can start while it's raining. But if it's a short rain that releases a lot of water all at once, it takes time for that water to flow down into the streams. And so your flooding is usually delayed by a little while, depending on what part of the world you're in. So that's an interesting thing. Where's my laser pointer? All right. Let's see. Flooding immediately related to the amount and intensity of precipitation runoff. Yeah. I mean, your flood is definitely going to be related to how much rain you get and how far it runs off the land that it falls on. So if we have a lot of cement and a lot of streets, that's not going to soak up any of that rain. It's all going to run down into the creeks. If you have a lot of trees and grass and things that will soak up that rain, kind of keep it from getting to the creeks, then you can have a little bit less of flood stage. Let's see, recurrence interval. How often a flood happens, and this is actually something that you hear in the news when they talk about floods. We also use this kind of when we talk about major storms. But the flood intervals, how often you can expect, on average, it's not going to happen like clockwork, how often you can expect a flood of that size. So like, let's say we live by a creek, and once every like 4 or 5 years, the creek comes up to the banks. It doesn't flood, but like the whole thing is full all the way to the top. It can't hold any more. That's probably going to be worrisome, because if that happens once every 5 years, then I could guess that once every 10 years, it's going to go over the banks. And once every 50 years, it's going to get really high where it might even fill up the bottom part of my house. And so you want to think about the things, even if they haven't happened yet, you want to look at your flood maps and see where it can happen and how often it does happen. And so one of the things, if you end up buying a house as an adult, if your house is anywhere close to 100-year floodplain, 100 years, not 10 years or 50 years, but the 100-year floodplain, you will have a hard time getting like a loan for it. You'll have a hard time getting insurance for it, because they know, okay, maybe over 10 years you might be good, over 30 years you might be good. At some point in time, you're going to be pushing your luck with a flood of that size, and your house might get flooded, and I don't want to be having you owe me money when that happens. So they'll be a little bit more careful about it. Let's see. Flash floods in zone 1. So now we're going to specific floods. Zone 1 is up in the mountains. So in order to have a flash flood up in the mountains, you got to have a lot of rain, caused by intense rainfall over a short duration of relatively small area. And the reason is everything's very steep. The water's going to run out of zone 1 super quickly. This is not going to take this like long time delay in between when my rain and my flood happens, because the water's moving very quickly in zone 1. And so if it falls very intensely for a short period of time, all that's going to end up in the creek and be flooded. But the good news is the flood is also not going to last very long because it's moving quick down the hill too. And so probably not going to be a big deal for a long period of time. Common in arid environments with steep slopes and little vegetation, following the breaks of dams, levees, or ice jams up in the mountains, then all your water's flowing downhill, and now you got a flash flood problem. These are just a couple pictures of flash floods. You know, a lot of people worry about the water itself, and the water is dangerous. You don't want to get your car caught in a flowing river or creek or whatever and have to be rescued, or maybe even worse. But a lot of times people just think of the water itself and don't think of the erosion that can happen here. And so if this river were a little bit higher, as a driver, you would just see just a little bit of water over the road. And you're like, I'm fine. I got this. I can drive through a couple inches of water. And what you don't see is that the river's literally taken the entire road out. And so when you drive into that couple inches of water, your car now just goes off the cliff edge and you're in like several feet of water being swept downstream. Same thing happened here. Obviously, these trucks didn't like start the day here. They thought they were driving over a complete road and ended up going off. And you can see, by the way, this truck is like face down here. This didn't happen while the truck was here. This truck drove off almost like a full cliff, thinking that they could get across. And so be careful when you're crossing areas that are covered with water and you can't see what's going on the other side. It's not just the water you got to worry about, it's other things. So downstream floods in zone 2. This is going to be a little bit different because zone 2 is not as steep, and you usually have the meandering river. And so these are often associated with floodplains. And so big areas where if I get a lot of rain, it's all going to come down. It's going to have this kind of delayed effect here. And if I get enough, when my river floods, the flood is going to cover a really wide area because I'm not in that V-shaped valley anymore. I'm in like a flat plain. Did I miss something? Let me make sure. Usually produced by storms of long duration, can be caused by combined runoff with thousands of tributary basins. So like I said, the funneling, where I get lots of little creeks and streams that all flow into one bigger river. It's just going to pile up and produce a flood. Let's see. So yeah, you can see here, this is your big wide part here. You're talking about a wide river to begin with, and then once it floods, I have a huge flat area next to the river that's all just going to take a lot of water. That's not a good setup. That's not where you want to be. If you buy a house here, you want to buy a house up on the hill. So even if it floods really, really bad, you're still not going to get floodwaters up to your house. Let's see, Mississippi River floods. So these are zone 2 floods. The Mississippi River floods a lot because if you haven't noticed, it goes all the way from Louisiana up to what, like Minnesota, or it's almost Canada. I don't know if it goes all the way into Canada or not, but it goes pretty much the entire length of the country from north to south. And so if you have a big rainfall anywhere in those northern states for several days, it's probably over several states, and all that just piles up as it comes down the Mississippi towards Louisiana. And so you get these really big floods happen sometimes. So 1973, 1993, 2008, roughly, 15, 20 years on each one. So not even like a 100-year flood, more like a 15, 20-year flood, and they get pretty big. So problems occurred despite flood defenses. They had flood walls and bottlenecks. They had levees. They do all the stuff. We try to keep it in control. But at a certain point, it's just going to be too much water. So lessons learned were levees provide a false sense of security. They work right up until they don't. And then when they don't work, it's pointless to have them. And so you got to make sure that your levees are ready to withstand what you need. And once they go, the people that are being protected by the levee need to have some sort of plan. You need to have something in place, because if the levee fails and you don't have anything ready, you're going to be in a world of trouble. Let's see. Levees result in less floodplain to soak up the water. Difficult to design levees to withstand high magnitude floods for long periods of time, which is true. So levees are what we build. And actually, if you've driven into Dallas, you've seen a good example of levees around the Trinity River. Let's see. Trinity River levee. Where are we at? It's kind of like this. This is not where I drive over. I drive over more on 45. Trying to find a better picture of it. Although that one's not too. Oh, fine. I'll just use that one. So here's a picture of it with their new bridges. That's not too bad. But when you're driving out to Dallas, you're going over 45, you go over this bridge, and the first thing you see is this really wide piece of land with like a tiny creek in it. It's not tiny, but it's a creek. It's not a river most of the time. It's tiny. There's not a lot of water going through it. There's just not a lot going on. Now, it does flow most of the year, so it's not like a seasonal creek or anything. But compared to the land that you have here, the amount of water that flows through it on a normal basis is small. Now, what we did, we built these hills. You can kind of see it because of the shadow right here, but on both sides of this wide plain are these really big hills. These are levees. So essentially when the river floods, it fills up this entire area, and because you can see all this coming out on either side is perfectly flat, when it floods, it will fill up those areas too. And so all of these buildings, basically most of downtown Dallas would be flooded. But we don't want it to be flooded. We're not ready for that. So we build these big levees that kind of hold the water in. And so the water has to get up above these hills before it actually floods on the other side, which is good as long as the hills work. As long as they're there and they're working, that's good. And we've got pretty good ones. We don't have real big floods in the Trinity River all the time. And these are maintained by the Army Corps of Engineers. So I don't think we've ever had any really major problems with the Dallas levees. But if we do, you can bet that all these homes and businesses right over here don't have pumps. There's nothing in place to pull all that flood water out if the dams and levees fail. And that's what they're kind of pointing out is sometimes we build these things to protect us and then we rely upon them. And we're like, oh, this is going to make sure that nothing bad happens. And you gotta be aware that there's always going to be some flood that's going to get over these and knock them down. Now, how often that happens, we don't know. When is it going to happen? I don't know, but you better be prepared for it. Kind of goes back to the electricity debacle we just had. In Texas, do we need the electricity grid to be winterized 24/7? No. But when it does need to be done, when the weather drops and we really need electricity, everybody's going to be mad if you didn't do it, and we don't have power to keep ourselves warm. So you got to plan for the unlikely. No matter how unlikely it is, you got to have some plan for it if it's important for people's property and people's lives. So we build these floodplains to try to keep the river in. It works most of the time, but when it doesn't, it's an epic failure. And then this is a good illustration about why we're going to do topographic maps, because it's all about elevation on where you get your flooding. So this is a flood of the Mississippi River. It's up in Missouri, St. Louis area. And so you can see the river flooded. This is normal stage for the Mississippi River in this area. This was where the flood waters went during this flood. And I'd point out, like, these people right by the river, you could be right on the river, didn't get any flooding at all. Like, you're perfectly fine. Where these people over here are like a mile from the river and got flooded out. So why did these people get flooded so far away from the river, and these people right next to the river didn't get any flooding at all? It's all about elevation, how high you are. I assume you have some pretty big hills right here on either side of the river, and so as the water rose, it didn't go above those hills, where over here, it's probably very flat right next to the river. So as the river rose, your water spilled out and came all the way out into those neighborhoods and areas, which is pretty bad. Now, hopefully, if the city did their job right, they would have known where the floodplains are and not allowed people to build large neighborhoods there. Maybe use it for farming or industrial. I mean, there's certain things that can take floods better than other things. But ideally, you'd want a city that kind of plans that and not leave it up to the homeowners. But that's why you check yourself and make sure your house isn't in a floodplain. And then Zone 3 floods. These are particularly dangerous because you can get a lot of water in them, and there's no real constraints on where the water goes. With the other two, you know where your flooding is going to happen. Everything's so flat in Zone 3, your flooding could really kind of go anywhere in any direction. This is an example they use every year. Well, of course they do. The PowerPoint doesn't change from year to year. But they have this little RV park, and they show how this flooding was caused by designs of the highway and the little town right here. So they show you a map, an old map from 1885, and they show you the river drainage that comes down here into this little bay and kind of drains out into the river. And then they show you that in 1889, they built railroad tracks and roads across all these and have that's the future side of the RV park. I doubt they have, well, maybe they have an RV park in 89. That could be a thing. And then they just keep building, and, well, I guess that's your most present day one in 89. But anyways, all of these bridges and things that are crossing these rivers are going to stop them up. They're going to limit that flow. And if the flow happens to be pretty high, you're going to have problems with where the water can go. And so you're going to have it pooled up, and that's what happened in that flood. Let's see, mega floods. So just like really big hurricanes and earthquakes and fires, the biggest ones happen the least often. So less frequency than your smaller floods. They obviously are more expensive, have more loss of human life and property, and can be really, really bad. So they're usually caused by storms over a long period of time. Monsoon season, if you will, like in the Philippines, appears to be more likely than unlikely that it's going to happen. Here's an example of your jet stream. So you can see that this air that flows right here through the middle has a high moisture content compared to the air on either side of it. And so if you get caught, not caught, but if you happen to live in an area that flows inside this jet stream, you're going to get a lot of moisture and a lot of rain. And so they're kind of showing here, this is going to be Southern California. And if this jet stream is bringing a lot of moisture, this is probably rainy season there, and they're looking at landslides. As soon as the fires stop, the water starts to come, and they start to have landslide problems. And that jet stream is kind of one of the reasons for it. Let's see, geographic regions at risk for flooding. Any place that receives rain and fall has the potential to flood. Just depends on how much you get and where it's going to go. Floods were number one disaster in the United States in the 20th century. All areas of the United States and Canada are vulnerable to floods. A single flood can cause billions of dollars of property damage and more than 200 deaths. We have flash floods here in Texas all the time because we get pretty crazy storms sometimes. Developing countries suffer much greater loss due to lack of monitoring facilities, warning systems, adequate infrastructure, etc. This is actually a pretty interesting map. This shows you all of the floods, all of the people killed, all the people affected, and the economic loss per, like, not country, but let's say a continent in a way. And so you have Europe, Asia, Americas, and Africa. Notice that, where are we at here? Where are we at? The Americas. Let's just look at the Americas. We've got one of the smallest portions of floods. So we receive relatively the least amount of floods, or close to the least amount of floods. But our number of people killed is higher. And our people affected, people killed is higher, people affected is lower. How does that happen?
Well, probably because they don't, I mean, like, you can still be affected without dying. I mean,
Yes.
Probably just not major floods.
I guess I'm thinking, like, I don't know. So I guess what that's saying maybe is that most of our floods don't affect a lot of people because we have preparations for them. So we have like levees and different controls to keep the rivers from flooding. But maybe when it does flood, we end up killing a lot of people because maybe we trusted too much in our levees and stuff like that. I don't know. Interesting. Asia has a lot of floods. A lot of people die from them. A lot of economic loss and people affected. And that's mainly because the Asian countries have high population density, and the ones that experience flooding have very small surface area. So I'm thinking of like the Philippines and Indonesia. Lots and lots of rain, lots and lots of monsoon seasons, and not really anywhere for you to go to escape that because they're small, like water. I guess it would be landlocked. No, it's not landlocked. Island. I guess island is the proper term for a piece of land surrounded by water. So yes, thank you everybody. Have a nice day. And we will continue tomorrow. Yes.